Alright, it's just another day, so I guess it's just time for another coding challenge. And we will try to solve some coding problem under 40 minutes as usual. Let me check if everything is fine. Just a reminder, this stream is for entertainment purposes only. And looks like we're up and running, so without further ado, let's see what we got here. Alright. Problems. And pick one. Nope. Did I call it? Did I pick it? Nope. One more time. Pick one. And it's hard. No, medium. Okay. Flip columns for maximum number of equal rows. Interesting. So if it's a binary matrix, why we have integer as an input? Sounds weird. You can choose any number of columns in the matrix and flip every cell in that column. I change the value of the cell from 0 to 1 or vice versa. Like converted. I see. Return the maximum number of rows that have all values equal after some number of flips. Didn't get it. Alright, so we have 0, 1, 1, 1. Output 1. After flipping no values, first row has all values equal. You can choose any number of columns in the matrix and flip every cell in that column. I change the value of cell from 0 to 1 or vice versa. Return the maximum number of rows that have all values equal after some number of flips. Maximum number of rows, okay, that have all values equal alright, so we can choose column to flip whatever we want, right? And then we return number of columns where either all zeros or all ones, like what's the maximum number of such number can be. All right, I see. So we have 0, 0, 0, 0, 0, 1, 1, 1, 0. Definitely, yeah, it makes sense to flip the first one, then we will have two. All right, yeah, I got it. I just don't understand still, why do we need integers and not booleans here? It just sounds weird in terms of memory standpoint, but whatever. All right, let's switch to the whiteboard and see on the example 3 here what could be an interesting algorithm. So okay, so the matrix is always what? I mean, I understand that M is matrix length and N is this. So M and N is between 1 and 300. All right, so obviously quadratic algorithm. So matrix Ij It's just to count the number of rows with equal values. It will take that amount of complexity. Now j is either 0 or 1, so just put boolean here the next time. All right, so whiteboard. Let's see. All right, so we have what? The following matrix, right? 0, 0, 0, 0, 0, 1, 1, 1, 0. So obviously, if we flip this one, then we will end up with 0, 0, 0. Sorry, no. One, it's 0, 0, no 0, right? And maybe we want to, oops, we want to use also black color here. So, and then is 1, 1, and 1, because we flipped it, right? And now we see that these two are interesting. So, idea number 1. Obviously, if I choose all columns, it won't change anything, right? If I choose n-1 column, is the same as choose another column, because we don't care whether they're zeros or ones. So at most, we need to choose n by half column, like half of the column we may flip. So how do we choose what to flip? It is interesting, right? It's not that straightforward as I think. Like, yes, we can just go one by one, or maybe two, or we don't know, right? Alternatively, we can go through every row and check element one by one, right? And then for every row, we will have indices which we need to flip in order to, right, in order to have all elements the same. So let's say in this case, all right, we have no indices because we have all zeros. In this case, we have index 2, right? Column 2 should be flipped in order to make it all zeros. In this case, column 2, right? All right, and then we see that, okay, if we flip this, obviously this will be what? This will be not, this will no longer contain all of the elements, but these two will, so it will be 2 versus 1, which is better. So the maximum we can get is the maximum number of rows, right? So max is 3. This is the best we can get in this problem. And we know that if we flip the last, we will get these two. So let me see. So what if we have something like this in this case, right? So we say, if we go into flip, no, yes, no, yes, right? So what if it's like this? I just wonder, right? Do we flip anything at all? Like if in this case we have, let's say, there will be never a case like this, right? So we always want to flip less elements, I guess, or maybe not. Let's see. It's interesting, right? So let's assume this is 0 and this is 1, right? So let's see. Like in this problem, okay, so we say here we don't need to flip anything. Here we need to flip, right, index 1, and here we need to flip, sorry, index 2, vice versa now, right? No, here is index 0, sorry. So 0 and here is 1 and here is nothing. So now basically the answer is, I guess, 1. There is no way we can flip it, right? Okay, we can make it 1 0 0 1 0 1. So this will be 0 0 1. This will be 1 0 1. Right, so yeah, let's see. So if we flip this one, so what we will get? 1 0 0 0 0 0 1 0 1. So now basically what we do, we move rows with each other in this case, right? But this is small matrix, so it's not clear what's going to happen if there will be more indices to flip. But this is exactly what we need, right? We need really only count like all those elements that have equal amount of column indices needed to be flipped to have minimum number of columns that needs to be flipped to have whatever is needed. All right, so I think I got the problem. So we have let's say vector of I don't know, vector of booleans, flip or not, or is it better to say vector of sets and compare two sets? Or can we just have vector of strings such that we just add indices via, let's say, dash or something, such that if they're equal, we know that those are. Okay, let's switch to the code and see. So the idea is we calculate this thing, either it's set or whatever, to just basically to compare identical columns that we want to flip in order to make it all zeros or all ones, right? All right. Let's see. Let's go to the default scene and start coding something already. So, all right, let me try first. I can change it later. So number of rows is m, right? So we can say size. So for every row we need to have a key, like how many columns we want to flip, and this will be always less or equal to half of the length of the matrix. All right, so that's what we do. All right, so let's see for you can say const out whatever row. You're not going to change the matrix itself in matrix, or do we want to? We need the index, right? So it's better just to say int I equals 0, I less than matrix size, whatnot, and I plus plus. So okay, now we need to check okay, let's say is it an ordered set or is just vector of something, vector of what, a boolean, right? Because we save on memory here. No, it's indices, so it should be int. Calls to flip, right? So we can just say for int j equals 0, j less than matrix whatever size, matrix I size, and then j plus plus, and I will say here that if matrix, let's by default assume that we always want it to flip to 0 and then change as needed, matrix equals 0, then we say goes to flip push back what, J. Now we say bool use once. So because by default we want to flip everything to once, right? Or not use, flip once. By default we want to flip zeros, but let's say we want to flip once. If goes to flip size is greater than what? Matrix I size divided by half, right? So let's say our matrix size is 7. The length of the row is 7. And we need to flip 4 zeros. So obviously instead of flipping 4 zeros, it's better to flip 3 ones, right? Instead. So let's say we have 4. 7 divided by 2 is 3. 4 is greater than 3. We say flip once. Okay. So now what do we do? Let's say string. We already have it, right? So we don't need it. 4. Then we need just set, I would say. Unordered set. I think this is goes to flip because we really don't care what's there. We anyway will do exactly the same thing one more time. And what do we do here? Now we check if flip once and let's call it not calls to flip but zeros to flip. Zeros to flip, right? And zeros to flip count J. Alright. And it doesn't contain the J. We say not bad. Oh, I didn't give a name. Ooh. Goes to flip. That's there we go. That's where this name is the good one. And it's not goes to flip, it's zeros to flip. Goes to flip I, right, for i's row is plus equal to string. We say what to string J plus I don't know, this, right? So else if so basically if something doesn't hold here, so if let's say we don't flip one, okay, let's see here, right? Let's do it like this so it's more clear. That's internal one. So if we're flipping once, that we don't want J to be in zeros to flip. and it's per minute. So else it's vice versa now, right? If we flip zeros, then we do simple thing. Then we say cost to flip plus equal to string j. So we do the same here anyway, but just it matters whether we flip zeros or one. So all of this is technically linear with respect to the length of the row, and this is number of rows, so it's the entire matrix. So it's quadratic because it still needs to be quadratic. All right, so now we have these hash keys. Now all we need to check here is so we have the key, right? Then we basically go in the opposite direction and start counting how many of such keys we have. And to this end, we can have an ordered map, right, so string is now the key and int is number of occurrences of this key, right? We know, let's say, unique keys, right? Unique keys. I can suggest this one. So we go through this vector 4, we say key or const out whatever key, right? We say what key goes to flip, we say unique keys, key plus plus. That's it. Now we say int max keys and obviously it's 0, and then 4, const out whatever key cnt in unique keys, right? Max keys equal max between max keys and cmt. Then we return max keys. All right, so the logic is as follows. So we start with checking which columns we need to flip, and by default we always choose the least number of columns, right? So to make either zeros or ones, and it doesn't really matter. Once we have this, we just for every row we have such key, which is basically a combination of j plus something. And once we have such key, which can be up to 300 elements with those separators. Key is large though, so the hash function can be a little bit slow here, but what we do here, we now say, okay, now we have this key, now we just count the unique keys and return the maximum number of rows occurrences that have the same amount of columns to flip to have it. All right. All right, let's just check directly if it works or not. I don't want to debug it myself. All right, we start with pushback, and obviously because it's now a set, we just need to say insert. It works. Why? All right, let's see. I doubt that I will pass all the checks like so easily. Most likely something gonna fail, obviously. All right, so expected 2, but we say 1. Ah. Exactly, right? So so maybe we should choose just one number where we want to flip, right? Let's say we always want to flip all to ones. It doesn't really matter technically, but what it, like in this case, we might flip the column 1 to 0 and another one to 1, right? And the keys are different, so to have 0 we need to flip last element, and here to flip to 0 although it's interesting. Let's just see out row I key is this, right? Row flips. And check what we've got. It sounds like it's somewhere here. It's a little bit weird. Okay, so for the first column we can flip the first element, right, the 0 column, such that we have all ones here, but obviously row 1 in this case won't be identical, so it's 1, right? So in this case it should be 2, but we have 1, and the reason is, let me see what's the right. Exactly, right? So we say that in first case we flip first element, in the second case we flip the second element, right? And the trick here is that once we flip the first element we have all zeros, and once we have the last elements we have ones, but once we flip the first element, right, the first column, we got 1 1 and 0 0. So the problem here, it is interesting. So let me think. So in my case, despite I need to flip the second column, I can technically flip the first column, right? So should I just let's see, calls zeros to flip, and the same thing calls ones to flip. So why not try both, right? Calls ones to flip. All right. So once we have this thing, right, we say, we don't need this. We basically say if flip once, right? Or we can start with this. Zeros to flip, if flip zeros, then we say call zeros to flip. We don't need this internal one, so it simplifies stuff for us, it's good. We say zeros, call zeros to flip to string I, if flip once. And then we have vice versa, call once to flip. All right, so once we have this and that, right, let's print now row I. Let's say 0 key for 0 to flip. Then 1 key, and we have calls 1 to flip I, right, just for our reference. Now I think so we have these unique keys, right? We have unique keys for zeros and unique keys for 1. So technically, if the key, if row 1, let's say, have the same key as row 2 in zeros, we can sum them up. But if row 1 have 0 key and row 2 have key 1, nah, I don't think it's gonna work like this. Let me just check. All right, so row 1, 0 key or key 1, 0. So in this case, 1 is correct answer. In this case, the problem is that all right, I see. I think I know how to do this. Almost. So we either check to make O ones, so the key gives us the number of columns that are either to make O ones or zeros, and because we can count both, exactly, all we need to do is do this once we have it, right? Is do this, we can call it zero key, this can be one key, and it goes once flip, right? And that's it, and the rest is the same. And let's see if it passes this thing now. Nailed it, under 40 minutes. Let me remove this cout thing. All right, so in terms of memory, we're super bad. We're super bad because it tracked those huge strings. Oh my goodness. Maybe at least we can make a pointer here, right? So we can just say 0 key, 1 key. Not sure though if it's but it wants whatever. Yeah, let's not bother with this thing. Well, let's see what else to improve. So we have vector of strings here, right? And it basically tells us unique key, how to sort this, and then we use this map and whatever. Whatever, we run out of time, so I don't think we can do any improvements here. Let's just run a couple of times more to see if we can get slightly better scores without the cout thing. Nah, not much. All right, so I see the best memory is this, and the best time is this. Let's see if we can combine it and get extra point or so. Okay, we've got better memory, but we still here. But it's still like 13% here and 5, so it's 18 total. I doubt we can get to 19. Okay, one last time, and whatever happens, happens. No. All right, so it's, by the way, the best time I've got here. Half a second, oh my god. And memory is one of the best, except this part. Whatever, so I'm okay with that. So we have 13 here, 5 points here. Let's switch to the whiteboard. Hey, at least we solved the problem, so what the heck? Not the most efficient way, though. All right, take a look at that. Huge scores. What's the goddamn front here? Right. All right. See you tomorrow.